Welcome to Math Tutor, where we support your math learning. We begin in continuation after Trigonometry 308. If you haven't watched episode 308, click on the link above. This is episode 309. Hunting angles for a trigonometric ratio. You may need to recall episode 306, Trigonometry Extended, episode 307, Trigonometric Graphs, and episode 308, lesser known trigonometric functions. Let's start with the point P, Q in the first quadrant of the unit circle. Can you solve for x for which sin x is q? If 40 degrees was your answer, remember that's only a solution between 0 degrees and 90 degrees. But what if the task is to find solutions for which x lies anywhere between minus 540 degrees and plus 540 degrees? To do this, let's begin with drawing the sine graph and locate the angles for which the outputs are q. One obvious angle, whose output is q, is the angle 40 degrees. All other angles that satisfy the equation have the same base angle. Beginning with the smallest angle that is a solution to the equation and is within minus 540 degrees and plus 540 degrees, we have minus 360 degrees plus 40 degrees, minus 180 degrees minus 40 degrees, good old 40 degrees, 180 degrees minus 40 degrees, 360 degrees plus 40 degrees, and 540 degrees minus 40 degrees. So there we have it, the solutions for x. As a do-it-yourself, solve the following trigonometric equations in the given intervals. To the left are points located on the first quadrant. To the right are templates onto which trigonometric graphs can be drawn. Pause the video if you would like to try it yourself. As for the first, we draw the sine curve. Identify the base angle 60 degrees. Draw the line y equals sine 60 degrees. Clearly, there are infinitely many solutions. But within the required interval, we have 60 degrees and 120 degrees. Moving on to the second, we draw the cosine curve. Identify the base angle 75 degrees. Draw the line y equals cosine 75 degrees. Among the infinitely many solutions, we restrict our focus on the given interval. The solution is minus 75 degrees. For the third, we draw the tangent graph. Locate the base angle 20 degrees. Draw the line y equals tangent 20 degrees. Keeping in mind the interval of interest, we have minus 340 degrees, minus 160 degrees, 20 degrees, 200 degrees, and 380 degrees. As for the last, we draw the line y equals minus q, keeping in mind the base angle of interest 50 degrees. Accounting for solutions that lie in the interval, we have minus 130 degrees and minus 50 degrees. Did you get all of them right? Let's solve the equation. Sin x equals minus half for which x lies between minus 180 degrees and 360 degrees, inclusive of 360 degrees. Let's do this without drawing graphs. We split the interval of interest into two parts, the negative part and the positive part. Since sign is negative, we focus our attention on the third and fourth quadrants. The absolute value of the ratio half is the sine of the acute angle 30 degrees, the base angle, which we keep ready on the quadrants of interest. So the required angles beginning from the smallest are minus 180 degrees plus 30 degrees, minus 30 degrees, 180 degrees plus 30 degrees, and 360 degrees minus 30 degrees. So, there we have it, the solutions. As a DIY, solve the following trigonometric equations in the given intervals. Try not to be tempted to use graphs as before. Pause the video if you would like to try it yourself. Beginning with the first, the absolute value of the ratio root 3 by 2 is the cosine of 30 degrees, the base angle, which we shall make use of very soon. Visualizing the given interval into two parts, the negative part till minus 150 degrees inclusive of minus 150 degrees and the positive part till plus 400 degrees excluding 400 degrees, we focus our attention on the second and third quadrants, where cosine is negative. The base angle 30 degrees is introduced into the two quadrants. The required angles beginning from the smallest are minus 150 degrees, 150 degrees, and 210 degrees. Moving on to the second. The output 1 is the tangent of pi by 4, the base angle which we keep aside for now. Visualizing a split in the intervals, the negative part and the positive part, and keeping to the first and fourth quadrants where tangent is positive, we build base angles pi by 4. The required angles beginning from the smallest are minus 7 pi by 4, minus 3 pi by 4, pi by 4, and 5 pi by 4. As for the third problem, 2 happens to be the secant of 60 degrees, the base angle which we shall exploit shortly. Visualizing the range of angles from 300 degrees to 500 degrees inclusive of 300 degrees and 500 degrees, and keeping to the first and fourth quadrants where cosine is positive and therefore secant is positive as well, we construct the base angles 60 degrees. The required solutions are 300 degrees and 420 degrees. Shifting our attention to the last problem, the absolute value 1 by root 3 is the cotangent of pi by 3, the base angle. On visualizing the interval from minus 11 pi by 2 to minus pi by 6, and keeping to the second and fourth quadrants where tangent is negative and therefore cotangent is negative, we construct the base angles pi by 3. The required solutions in decreasing order are minus pi by 3, minus 4 pi by 3, minus 7 pi by 3, minus 10 pi by 3, minus 13 pi by 3, and minus 16 pi by 3. Did you get all of them right? As an open problem, try solving the following trigonometric equation in the given interval. Do share your answers in the comment section. If you like the video, don't forget to hit like. If you think it's worth a share, do share. If you wish to stay updated about new videos, do subscribe. Oh, and don't forget to leave us a comment if you want